and representing data in common formats, and a lot of what you can do that's exciting, taking data from across different kinds of systems and mashing them up. And I want to share with you some of the work we've been doing at Harvard Medical School in a project called SMART. It stands for Substitutable Medical Apps. And it's a project that's sponsored by the ONC, the Office of the National Coordinator for Health Information Technology. And the idea is to build an app platform where third-party medical apps can plug into electronic health records and personal health records and extend the functionality of those systems with apps. So I'm going to give you a really quick tour of the architecture that we've put together and show you some of the RDF basis for the way we expose data. And I'll also show you some examples of some of the apps that we've been building using these data. So the 30,000-foot picture is we're providing a platform for folks to build apps that plug into these systems. And there's 4 core areas, things that we provide for apps. So the first is user interface, some way to build an app with a UI that can plug into existing electronic medical record systems and other health IT. The second area, where we'll spend most time today, is data. So we have consistent representations of the data in these systems. So if you're building an app, you know what the data are going to look like. And there's some contextual data there, but mostly there's medical data, all the blood pressures and lab results and patient demographics and stuff that your app needs to make sense of a patient record. And then there's an API for accessing those data, and there's authentication so that users can delegate access to records to an app, so an app can access data on behalf of the user. So a couple of quick pieces of vocabulary before we jump into this sort of smart ecosystem. We've got things that we call apps, which are at the top of the screen here. And apps are individual units of functionality that provide an end user some convenient function. So I'll show you a few apps today. One that tells whether a patient is taking a statin drug or not. We could see apps that calculate cardiac risk, or apps that display a growth chart for a pediatric patient, or analyze blood pressures and determine if they're normal. Those are apps. On the bottom of the screen here, we see what we call smart containers. These are health IT systems like an EHR or a PHR or a data mining platform that have individual patient-level health data in them and expose them through the Smart API, that's the line down the middle here, so that apps can use the data. So there's apps and there's containers, and the apps talk to the containers through the Smart API. So that's the vocabulary we're talking about here. And like I said, I want to focus on the data, because that's really the hardest piece in the health IT ecosystem. And I won't talk much about contextual data like who launched the app and was it an authorized user. I'm going to focus on the medical data. And there was this question when we started this project in 2010, how are we going to represent medical data? And the vast majority of clinical data that travel around in the sort of health IT ecosystems travel around in documents. So there's this model of document-oriented exchange where you write up everything you want to say about a patient and you ship it over the wire from point A to point B. And that might be a pretty good model for if you're sending a patient home from the hospital and you want to make sure their primary care doctor has all the relevant information in one place. Or if you're transferring a patient from one facility to another. The document-based model is pretty nice. But if you're trying to expose data for an app, you want something more granular. The app might like access to a discrete list of blood pressures that it can query, for example. So this is a quote, again, to reference the Presidential Council of Advisors on Science and Technology, the PCAST report. Here's a quote: "The best way to manage and store data for advanced analytical techniques is to break them down into the smallest individual pieces that make sense to exchange." And that's the kind of approach that we've taken in SMART. So we have some very simple data models. I'll give you an example of what some of them look like. And then behind those data models, we have standard terminologies, things like SNOMED CT for representing problems, RxNorm for representing medications, and LOINC for representing lab values. So we don't need to model a lot of the detail that goes into these concepts. We can focus on an information model that's pretty slender and relies on standards-based vocabulary to say a lot more about the concepts, and we don't have to maintain those things. So we have kind of an 80-20 approach where we focus on common sort of clinical summary data for patients. We're not trying to model everything that's out there, but we're trying to be very specific about what these payloads look like. So if a developer is trying to build an app on top of this API, they know what they're going to get. They know what codes they're going to see. They know what fields are going to be populated. And we have this extensible representation of the data in RDF. So I'm going to show you just a quick link to our developer documentation. This is a page on the web. I should say that all this work, including the documentation, the API specs, our reference implementation, is all available open source under an Apache 2 license. And this is a quick summary of the data types that we have right now in the system. So these are clinical summary data, things like allergies, patient demographics, immunization, lab results, a problem list, social history, vital signs. And for any one of these data elements, This is wiki documentation that's auto-generated from an OWL ontology. So you can see an example of what the data models look like in a few formats, and you can get a descriptive overview of what the required fields are and cardinalities and what's optional for a set of vital signs. For example, vital signs here explicitly can have a heart rate and oxygen saturation. And we try to have sort of idiomatic RDF, so we have a predicate that has oxygen saturation, which is attached to a set of vital signs. So a developer can look at a payload and sort of understand what it's all about, and not just have to infer from a LOINC code, which might be quite long and unfamiliar, what the data mean. So I want to show you a few examples in the next 4 minutes of the kinds of things that people can do with these APIs. So I always start with kind of the hello world of smart apps, which is a very simple app called GotStatins. This is running inside of what we call our Smart Reference EMR. So it's an implementation of the Smart API for developers to sort of figure out how the API works. We host this on an open sandbox site at sandbox.smartplatforms.org, and you can also download it yourself and run it on your own machine. So this app, you can see the output. The user interface is pretty trivial. It just, there's a patient record, which I didn't show you that part, but the patient was automatically selected. And based on the patient's medication list, this app will go in there, figure out if the patient is taking any statin drugs, and then print out the answer. If I find a patient who's taking the statin, it's ever so slightly more interesting. It'll say the name of the drug. But why I show you this app is to show you the source code for the app. So I'm going to go ahead. This app is embedded in the EHR using HTML inline frames. So I'm going to look at the source code for this frame here that's printing out the patient's statin status. And I'm not going to get into any detail here. I will in a moment. But the whole page, basically, the whole app fits in one page of HTML and JavaScript. And that's the real point, is that we want to make it simple for developers to do simple jobs. So I won't tell you the details, but the app goes in and gets the list of medications for the patient with a simple JavaScript call. That comes back as RDF. But it's also queryable through a kind of idiomatic client library, which is accessible as JavaScript objects. So if you're building a JavaScript app, you don't have to know much about RDF to get started. I'll talk about that a little more in a lightning talk. But then it can iterate through those meds, figure out which of them is a statin drug, and print out the answer. So that's example number 1, very quickly. Now, how does it actually work? How does it figure out which drugs are statins? Well, here I'm going to show you an example of a couple of Sparkle queries. Because the app gets the data back in RDF using consistent coding systems, this app is able to do a mashup. It's able to mash up data from the patient record, this Smart API. It can pull out all the medication codes and mash those medication codes up, the patient-specific data, against vocabulary data that are hosted elsewhere. So there's a concept server at BioOntology. We've talked about it already a bit this afternoon. And this app is able to write a Sparkle query against that Sparkle endpoint and say, here's a list of drugs this patient is taking. Can you tell me if any of them are statins? And how does it do it? Well, it does a bit of a crosswalk. It says, for any of the drugs the patient is taking, look at all the ingredients in that drug, look up the concept for those ingredients in the UMLS, get a label for that concept, by the way, so we have something nice to print out later, and then figure out, according to the National Drug File terminology, which of those drugs has a mechanism of action, which is an HMG coenzyme inhibitor. So that's to say which of them has a mechanism of action of a statin drug. So that's a Sparkle query that mashes up the patient data with reference data about the terminology, and you're able to get back interesting results that make sense for end users. One more example, which I won't get into, is a query that could help you split up a medication list into medications that are relevant to diabetes, in other words, that are used to treat diabetes, and medications that aren't. So if you're looking at a patient record with 20 medications, as a clinician, it's a cognitively demanding task to try to separate those at a glance into the ones that are relevant for diabetes. It's really nice if you can mash up these data with authoritative reference sources that help you do that and just segment. So at a glance, you can see exactly which meds are diabetes meds and which aren't. One more example I'll show you is an example of an open source app that we released last month, just to show you something a little glitzier that we're doing on top of the APIs. This is a pediatric growth chart app that was designed in collaboration with the Fjord designers and implemented as an open source app that takes patient historical growth chart data and does kind of a standard thing using a bunch of best practices for representing growth curves. And you can do some cool stuff, like if this is a patient, for example, who's a premature baby or who has Down syndrome, you can compare where they fall on disease-specific growth charts versus standard growth charts. And you can get a parent-specific handout that you can print out for parents to use. So we really want to make these data open and accessible for developers to start building things with the clinical data and making those data work for clinicians and for patients and consumers in ways that we don't have to think of ahead of time. We want to see people do really cool stuff on top of these APIs. So that's the 10-minute intro to SMART.
That are more directly applicable than human healthcare, in which the advantages of interoperability can be made more explicitly without the cost and the political policy bulkhead that you have to push through in order to get something done.
Okay, let's take one more comment over here. I guess Matt, and then we're going to have to go to the lightning talks.
Academic dental centers in the United States use the same dental electronic medical record. It's called Axiom, and they're joined in a confederation called COCORI that's really interested in making all of the data from all of the dental schools interoperable and accessible and queryable for these types of things. So I hear what you're saying as far as veterinary, but I mean, I think you have a very receptive audience
In dental, yeah.
I mean, they're spending lots of money on it, and we're trying to work on it right now. They use IV2, of course, but if there was 10 people that said, hey, we'll give you free technical support, use RDF instead, I mean, that they would go to it in a heartbeat.